What happens when you fall into a black hole? Have you ever looked up at the night sky and wondered what lies beyond the stars? Among all the mysteries of the universe, few are as fascinating nor as terrifying as black holes. These invisible monsters, scattered throughout the cosmos, can swallow entire stars, bend light, and distort time itself. But what if, instead of just looking at one from afar, you actually fell into a black hole? What would you see? Would you die instantly? Or would something even stranger happen? Today, we'll take a slow, vivid journey into that question step by step, exploring exactly what modern physics suggests happens when you fall into a black hole. So, fasten your seatbelt. This will be a one-way trip to the most extreme place in the universe. Part 1. What is a black hole? To understand what happens when you fall in, we first need to understand what a black hole really is. A black hole is not an object in the usual sense it is, a region of space where gravity is so strong that nothing, not even light, can escape. Imagine compressing the mass of the sun into a sphere just a few kilometers wide. That's how dense a typical stellar black hole is. They form when massive stars far heavier than our sun run out of fuel. Without the outward pressure from nuclear fusion to support them, their cores collapse under their own gravity. If the collapsing core is heavy enough, it keeps compressing until space-time itself caves in, forming a black hole. At the very center lies the singularity, a point of infinite density where the known laws of physics stop working. Surrounding it is the event horizon, the boundary beyond which escape is impossible. If you cross that boundary, you can't come back, ever. Part 2. Approaching the monster now. Imagine you're an astronaut on a mission to study a black hole up close. You're approaching slowly, drifting toward a massive dark sphere, surrounded by a glowing ring of gas, the accretion disk. This disk is made of matter being torn apart as it falls toward the black hole. Friction and gravity heat it to millions of degrees, making it shine brighter than an entire galaxy. As you get closer, you start to feel strange effects. The pull of gravity on your spaceship is no longer uniform. The side closer to the black hole feels a stronger tug than the side farther away. These differences are called tidal forces, and they will become deadly very soon. If this were a small, stellar mass black hole, you'd never reach the event horizon alive. The tidal forces would stretch and tear you apart thousands of kilometers away. But let us assume you've chosen a supermassive black hole millions or billions of times heavier than the sun. In that case, the event horizon is so large that the gravitational gradient near it is gentle. You might cross it alive, at least for a short time. Part 3. Crossing the event horizon. As you fall closer, something eerie begins to happen. From your ship's camera feed, you see the universe behind you stretch and distort. Light bends. Stars curve around the edges of the black hole like reflections in a funhouse mirror. If your friend watches from far away, they see something completely different. To them, it looks like you're slowing down. Each second, your movement appears slower and slower as you approach the event horizon. Your signals become redder light waves stretched by gravity until they fade away entirely. To the outside world, you never actually cross the event horizon. You seem frozen in time, suspended forever at the edge. But from your perspective, everything feels normal. Time continues to tick, as usual. You see the clock on your wrist moving, your heartbeat steady. And then, without fanfare, you pass the point of no return. No light escapes from around you now. You are inside the black hole. Part 4. The strange realm inside the event horizon. The very structure of reality changes. In normal space, you can choose to move forward or backward. left or right, up or down. But inside, all paths lead inward. Moving closer to the singularity isn't a choice that's as inevitable as moving forward in time. You can't stop, you can't turn around, you can't escape. The deeper you go, the stranger it gets. The outside universe appears warped behind you, a tiny, distorted sphere of light shrinking in the darkness. The stars you once saw are now smeared into streaks by the curvature of space-time. If you look outward, time itself seems to speed up. You might even see the distant future of the universe unfold in moments, galaxies aging, stars dying, everything fading into darkness because time outside your black hole runs faster than yours. It's a terrifying and beautiful sight. The end of the universe, visible in seconds. Part 5. Spaghettification. As you continue to fall, tidal forces grow stronger. Gravity pulls more on the parts of you closer to the singularity than on the parts farther away. Your body begins to stretch lengthwise and compress sideways. Physicists call this process spaghettification, and it's exactly what it sounds like. If the black hole is small, you'd be ripped apart long before reaching the center. If it's supermassive, the stretching might be gentle at first, but eventually, the difference becomes overwhelming. Your bones stretch, your atoms tear apart, and even the particles that make up those atoms are pulled into a thin stream of subatomic spaghetti. No one truly knows what happens beyond that point. Physics breaks down before we can describe the final moment. Among all the mysteries of the universe, few are as fascinating or as terrifying as black holes. Part 6. The singularity, and now the end. The singularity, a place where density becomes infinite, where time and space lose their meaning. Every law of physics we know fails here. General relativity predicts that everything collapses into a single point, but quantum mechanics refuses to accept infinities. Some theories suggest that matter could be transformed, not destroyed. Others propose that the singularity might actually be a bridge to another universe, a wormhole, or a white hole that spits matter out elsewhere. But these are just speculations. We have no way to test them. Once you reach the singularity, your journey and any information about you is gone from the observable universe. Or is it? Part 7. The Information Paradox. This brings us to one of the greatest mysteries in physics. What happens to the information that falls into a black hole? According to the laws of quantum mechanics, information can never be truly lost. But black holes seem to erase everything they consume. Stephen Hawking discovered that black holes slowly emit energy now called Hawking radiation and can eventually evaporate over billions of years. If they disappear completely, where does the information go? Some physicists believe it's somehow encoded in the radiation itself. Others think it might remain on the event horizon in a two-dimensional form, a concept known as the holographic principle. If that's true, then maybe falling into a black hole doesn't destroy information. It only transforms it, preserving it in a strange cosmic code. But for now, the truth remains hidden behind the veil of the event horizon. Part 8. What an outside observer sees from far away. Your friend who stayed behind keeps watching. To them, you never cross the event horizon. Your image just slows, dims, and fades into red light. Eventually, you vanish completely, absorbed into the glowing disk. For you, the fall lasted seconds. For them, it looks like you're stuck forever on the edge of the black hole, frozen in time. It's a haunting idea. Two observers, witnessing two completely different realities, both correct in their own frames of reference. Time itself becomes subjective, relative, distorted by gravity. Part 9. A cosmic end. OR, a new beginning. So, is that the end of the story? Maybe not. Some physicists suggest that singularities don't exist in the way we imagine. They may be replaced by something called a Planck staron, incredibly dense core where quantum pressure balances gravity. If that's true, the matter and energy falling in might one day bounce back out, releasing everything the black hole ever swallowed. In that sense, black holes might not be eternal prisons, but temporary gateways to renewal. The death of one universe, perhaps, could seed the birth of another. We don't yet know. But what's certain is this: black holes force us to question the very nature of time, space, and existence itself. Conclusion: the beauty of the unknown. So, what happens when you fall into a black hole? You approach a region where the known laws of physics begin to blur. You cross a horizon where light can no longer escape. You watch the universe race into the future before your eyes. And finally, you're torn apart by gravity, your information scattered into the fabric of space-time itself. It's a journey no one can survive, but one that reveals just how strange and how beautiful the universe truly is. In the end, black holes are not merely cosmic destroyers. They are reminders of how much we still don't know, and how every answer in science leads to even deeper questions. So next time you look up at the night sky and see the Milky Way shining across the darkness, remember that somewhere, far beyond those stars, lies a black hole silently spinning warping space, devouring matter and bending time, a cosmic gatekeeper guarding the deepest secrets of the universe. If you love exploring the mysteries of the universe, from black holes to the secrets of time, don't forget to subscribe. Every week, we uncover new and mind-bending stories that will make you question what's really out there. Hit that subscribe button, turn on the notification bell, and join our community of curious minds, because the next mystery might just change the way you see the universe.